So folks, today we are having a webinar on Big Data and Hadoop session. So let me quickly see who is joining for today's webinar. Okay, so pretty much everyone has joined today's webinar. So folks, let me quickly get started over here. Okay, so before we actually start discussing about the webinar itself, I would like to give a quick overview on the LMS portal of Edureka, how it works basically. So folks, here is the LMS portal. All that you are supposed to do is just log into the portal and just go to the courses link and click on the My Courses tab. So basically you will find all the courses you guys have registered for. So since this is going to be a webinar, I'm sure that so far no one would have been registered. So I just wanted to walk you through how the system works basically. Even if you guys are interested, let's go through this all courses tab. You will find a list of all courses over here. Okay, currently going on under Edureka. So however, welcome on board folks. So basically for one of the most happening sessions, Big Data and Hadoop. Okay, so let me quickly pull up the presentation for today. So the topic of discussion for today will be very technical in nature. I will not go through any of the theoretical aspects. We'll just try to discuss some of the technical aspects. So before that, I would like to introduce myself. So folks, my name is Mahesh. Basically, I'm a big data expert working in the big data industry since 6 years, having versatile domain experience as well. So I'm basically a data scientist applying both data processing techniques plus data analysis as well. Okay, so I just want to keep the introduction very short so that we'll have more time for discussing the actual technical aspects, folks. So if everyone is able to see my screen and hear my voice, please quickly say yes or no over the chat window so that I can quickly start with our discussion. Excellent. So it looks like pretty much everyone is able to see the screen. Okay. So folks, today I'm going to talk about reduce side joins in Mapreduce. So what is the importance of joins within the Hadoop framework? So how basically joins could be achieved within the Mapreduce. Okay, so however, there are multiple frameworks around available for us within the ecosystem. So our point of discussion, which allow you to basically do the joins. Today, our point of discussion will be on top of Mapreduce and see how to achieve the joins within the Mapreduce framework. Okay. So the objective for today is basically we'll try to understand what is a reduce side join, why reduce side join is more important, and then where we actually use Mapreduce, then a quick walkthrough on the Mapreduce workflow. After that, I'll actually talk about the steps involved in implementing a Mapreduce program. Finally, we will also go through an example program as well to implement the reduce side joins, folks. Okay. So does that sound like a good plan? So let's move on then. Okay. So why we need to join the data? So first of all, we need to understand the difference between the Hadoop framework and the traditional and the data warehousing frameworks. So data warehousing or relational databases, pretty much they come in hand for doing the data joins by default, because either the relational databases where you are actually strictly defining the schema and binding that schema to your data, and you are actually validating all your records against the schema upfront, you load the data into the tables. So with all those things in place, which in fact, relational databases also maintains the indexes as well. So with all those things in place, it's very easy for you to actually achieve the joins between two different tables in either relational databases or in data warehousing kind of data warehousing tools. However, when we are talking about the Hadoop framework, so basically Hadoop comes with both storage engine as well as the compute engine combined together. So when I say storage engine, we have got HDFS, Hadoop Distributed File System, and we have got the compute grid, which is called as basically AND now. AND stands for Yet Another Resource Negotiator. So there are a few other acronyms for AND as well. Okay, so however, let's stick to some standard definition over here. So now that you are actually having the data in the form of the files within the Hadoop framework, it will be quite complex to achieve the joins. However, with the advent of new DSL specific languages on top of Hadoop, make our lives easier to achieve the joins, like say Hive or Pig kind of frameworks basically allow you to perform the joins quite easily as opposed to Mapreduce framework itself. However, it's tedious to understand how the Mapreduce framework how within the Mapreduce framework you could achieve the joins. It's because all these DSL languages we are talking about, let's say Hive or Pig, they actually depend upon Mapreduce in the sense that whatever the queries you write within the Hive framework will get converted into Mapreduce job, and the Mapreduce job will get executed on the Hadoop cluster. In the same way, whatever the command you execute within the Pig framework, so that command will get internally transformed into a Mapreduce job, and that Mapreduce job will be executed on top of Hadoop cluster, folks. So that's why it's very crucial for us to understand, the underlying programming jargons within the Mapreduce itself. So let's take a simple example over here. Let's consider that I have got two different files, even though I have actually organized the data in the form of a table over here for your understanding, for your intuition. However, the data will be in the form of a file. So if you consider these two files over here, we have got customer related information. One file basically consists of customer ID, name, and then the item. Then the other file consists of customer ID, city, and phone. So to keep it simple for today's discussion, I have taken a very basic example over here because our intent is to understand how to implement a reduce side join. Okay, however, Mapreduce is designed to handle most complex data sets. Okay, most unstructured data sets as well. To get the complete details on, one needs to join both the data files. In order to get the information from both these files, you need to somehow join the data between these two files. Not really tables, I'm just calling it as files. Using joins, we can achieve data, we can generate data which would be useful and sensible based on some key here, which is customer ID. So basically, considering these two data sets, obviously, we can easily identify that we could do the join between a column called as customer ID within these two files. Okay, so let's move on here. So I just have shown a sample data over here, how the data will look like after you do the join on top of the customer ID. Okay, so before we talk about what are the different ways to achieve joins within Mapreduce framework, it's quite important for you to understand the significance of the joins itself. So joins are kind of the basic fundamental programming, fundamental way or technique for you to do the data analysis very quickly, especially because you get the data sets from different sources. Okay, so when you are getting the data from different sources, it would become quite obvious that you might have to do the joins between those data sets seamlessly so that you could analyze the data sets. Okay, so that's anyhow, even in relational world, a data warehousing world, or even in big data world, so it's pretty much has the similar impact. So However, as we all know, achieving the joins again in either relational or in data warehousing, it's quite simple in nature. Since we are dealing with the raw data over here in the form of the files, so it is a little bit complex in achieving in Mapreduce, but not really true because we have got multiple other frameworks which help us to do the joins. However, since our target is to see how Mapreduce implements it for today. Okay, so here are two important ways I would like to highlight through which you could achieve the joins. One is map side joins and the other one is reduce side joins. Okay, one is map side join and the other one is reduce side join. Okay, so guys, my assumption here is basically you're all at least a bit familiar with the Mapreduce framework. So that's why I'm using these terms like mapper and reducer. However, I do understand that some of you may not be, even knowing the basics of Mapreduce. So give me a little bit of time so that I could explain about what is a Mapreduce framework, what are the key components involved within the Mapreduce framework, and what is the workflow within the framework itself. Okay, so then we will go ahead and implement the program. However, here I would just like to bring up some level of insight or understanding on achieving the joins in Mapreduce. So as I mentioned, we have got two different ways to achieve the joins. In general, it depends upon the data sets you are dealing with and the state of the data, so that based on these two aspects, you would choose any of these types of joins. Okay, one is it depends upon the types of the data sets itself. Also, it depends upon the state of the data as well to determine which kind of joins you would be more helpful for you to perform. Okay, so let me start with map side joins first before we go back to reduce side joins. So so far, are we all following, guys? Oh, okay. I can see Varun could not hear me, and Samuel has a question, by the way. Okay, so I think Varun, are you able to hear me now? Looks like pretty much everyone is able to hear my voice loud and clear. Okay, so looks like there is some issue from your side, so I would expect you to reconnect to the webinar so that the issue will be solved. Okay. Okay, so Samuel says, what kind of knowledge is required to understand this webinar? Don't worry, Samuel. I do understand that we're all, at least you're all new to the system. Most of you at least are new to the system. So give me a moment. Let me first explain, the problem statement, and then let me go into the fundamentals. So that's where it will be more clear. Okay. So folks, please try to concentrate here and try to just understand, just try to correlate whatever I am speaking here with your, general relational world or, data warehousing world, basically. Okay. So as I was talking about, which types of joins could be used at what scenario, first let me start with a map side join and try to understand where all it could be applicable. Okay, so let's take this case. There are 2 to 3 different types of map side joins. Okay, there are 2 to 3, there are 3 different types or 3 different ways to achieve map side join. So what are those 3 different ways basically? So one is called as side data distribution. And the second type is basically called as using distributed cache. And the third type is basically used by using a a class within the Mapreduce framework called as composite input format. Okay, so I'm sure most of you are getting afraid of whatever the terms I've been using, but don't worry. I'll just try to keep the things more simple as possible. So if I just come out of the technical world, if I try to explain you in simple language here, so basically one of the key approach of choosing a map site join will be, let's say if you are having two different data sets, one with very huge data and the other with very small data. For example, if you are processing or if you are analyzing weather related data, okay, so obviously we all know that the weather related readings captured by the sensors are very high voluminous in nature. So you are dealing with very large data sets over here. At the same time, if you try to join that weather related data with the states of that particular country, okay, or else the stations where these weather recordings has been recorded, okay, so the amount of the station specific data will be very, very less in nature, maybe somewhere around 1 MB or 2 MB kind of volume. Okay, so you are having some terabytes of data sitting in the HDFS. Also, you have some states or stations related information which is very small. Okay, so this is a very good use case for going with map site join. Okay, this is a very good use case where you should consider map site join as your best friend. And it's very easier to achieve the map site join on this kind of data sets as well. Then the second use case is basically if you want to perform a very efficient join. So if you do not really have more time to wait to get the joins, okay, assuming that the data is already pre-processed, then again the map site join is the right way to implement the joins on such pre-processed data. Okay, so these are two key considerations for map site joins. So it happens on the map site itself. So don't worry what is a map, what is a reduce. I'll just talk about them in a moment. And then done within memory. One data is big, other data is small, just now I explained. And then it's a very expensive operation because it expects the data should be pre-processed for some use cases. Okay, then moving on to reduce site join. Basically, this is the inbuilt mechanism within the Mapreduce framework itself to achieve the joins. So it's basically inbuilt. There is nothing as such you are trying to do here to achieve the joins, because the framework itself has the ability to do the joins by default. All that you should do is you should know how the framework behaves. Based on that, you should make sure that the data will get joined based on your requirement. So today our point of discussion will be reduce site join, as I mentioned. So it happens on the reducer, so done off memory. So the greatest advantage doing off memory is basically both the data sets could be highly voluminous in nature. So no matter if the first data set is some petabytes of data and the second data set could be terabytes or petabytes of data set, still you could easily perform the joins between these two data sets with reduce site join. Okay, and it's very inexpensive operation in the sense that you no need to really write a very complex code. Because it's inbuilt within the framework itself, it's very easy to achieve. Okay, so I'm sure most of you would have got confused about what is map, what is reduce, so why we are talking about joins happening at map side and reduce side. So give me a moment. So do me a favor, just for waiting for another couple of minutes, another 5 minutes, I'll talk about all these things in detail. Okay. So where should reduce side join be used? So these are different key considerations for reduce side join. Basically, if I would like to highlight, joining data is arguably one of the biggest use cases of Hadoop. So joining petabytes or terabytes of data is one of the biggest use cases of Hadoop because most of the analysis happens over joining the data sets. And then when one needs to implement joins, simple steps. Okay, reduce side joins are straightforward due to the fact that Hadoop sends identical keys to the same reducer. So by default, the data is organized for us. So I know that this is very complex statement, but it will be crystal clear in a moment for you. I'll explain about that in detail, folks. Okay. So let's move on here. First, try to understand what is a mapper and reducer. Then we'll come back and try to read those points so that we'll get good enough understanding. So before we go ahead with reduce side join, let us refresh quickly about what is a Mapreduce, what is Mapreduce framework, what is a mapper, what is a reducer, how mapper and reducer will communicate with each other. So let's try to understand all these points over here. Okay. So even before that, so let's try to understand what are the applications of Mapreduce. Okay, so the general applications of Mapreduce framework, Mapreduce programming paradigm is everywhere, but I just wanted to highlight, by taking a very simple use cases over here. So Mapreduce can be used for analyzing the weather data sets and to predict, the weather itself. And to do the weather forecasting, basically, you can leverage on Mapreduce kind of programming paradigm. Why? Why should I leverage on Mapreduce kind of programming paradigm? Is it really new kind of technique which is being introduced with Hadoop? Absolutely no. No, because Mapreduce programming paradigm is been existing since ages with very older languages as well, like Fortran. If you consider any of the traditional native languages, most of them also already had or at least used Mapreduce kind of programming paradigm. But what makes Hadoop so interesting? Let's try to understand that here. So first of all, even before that, let's try to understand what is actually a Mapreduce framework is. So folks, Mapreduce programming paradigm is all about, instead of sending the data to computation, you just pass the computation to the data itself. So that's the core paradigm of the Mapreduce. Okay, so you are not actually sending the data to the computation. Instead, you are just sending your program or sending your computation to the data so that you are analyzing the data in its location itself, through which you are achieving high performance. Okay, also high performance processing high voluminous data sets when you are processing high voluminous data sets. Also, most importantly, Mapreduce follows something called as divide and rule kind of policy, where it tries to operate or it tries to process the data by chunking down the data into different pieces and going to each piece and trying to process each such piece independent to other piece of data. Okay, so that's how it basically achieves the parallelism infinitely. Let's say if your data is sitting across 1,000 nodes, you can just write a simple Mapreduce program and let the Mapreduce framework take care of processing the data residing in all those 1,000 nodes in parallel at the same time. Okay, so that your processing time will be reduced drastically. Okay, so you are seamlessly leveraging on all the resources, computing resources of all those nodes. Okay, so why basically for weather datasets? Because weather datasets are very high voluminous in nature. So you are dealing with some terabytes of data. So you need to have a Mapreduce kind of parallel programming technique to process these huge datasets in parallel. Then de-identify personal healthcare information. So this is another very, very interesting use case, especially because you are nowadays with the advent of cloud, with the advent of internet, basically we are able to capture the EHR or EMR records, electronic healthcare records, from different hospitals. The volume of these EHR or EMR datasets are very high in nature. So especially if you consider one of the interesting use cases in healthcare domain is if you want to outsource the data from one company to other company, you can't simply share the data as is to the other company for various reasons, because health specific data is highly sensitive in nature. So that's where you need to encrypt the data and then you could be able to share that data sets, folks. Okay, so this is another interesting use case where again Mapreduce comes into picture. Okay, so folks, are you all able to hear me properly so far? Because I can see Sri says she couldn't hear me properly. Sri, are you able to hear me now? Okay, so looks like Sri has an issue from. Okay, so now he's able to hear me. Okay, so let's move on, folks. Okay. So where Mapreduce is used. So let's try to understand, where Mapreduce is coming from and what kind of use cases it solves. So if you see here, Mapreduce framework basically is been, published by Google. So Google has actually published a couple of papers. One is GFS, Google File System, which is the distributed file system running on top of the commodity hardware. Okay, and then Mapreduce, which is called as Google Mapreduce. So these two papers they have published long before. Okay, so what Apache what Apache did is basically, so not really Apache. Let me talk a little bit about Yahoo also here. So what Yahoo did is basically they have taken that white papers as a reference and they have built a framework called as Hadoop. Okay, so Yahoo has created the framework called as Hadoop, and they have outsourced Hadoop framework through Apache. So now, so Apache is Apache Hadoop is a core framework available for us as open source framework. However, there are many third-party distributions for Mapreduce folks. Hadoop folks. So Apache Hadoop basically comprises of many ecosystem frameworks, but whenever I'm saying Hadoop, it basically means it's nothing but HDFS, Hadoop Distributed File System, which has been developed on top of GFS, and then Hadoop's Mapreduce, so which has been implemented on top of Google's Mapreduce, and then now we have got ARN as well. ARN basically is a compute grid for Hadoop for the generation 2. And then there are some ecosystem frameworks as well, like Pig, Hive, and HBase. So Apache via Apache, now we can access the open source Hadoop. Then used in. So where actually MapReduce is used. So it's basically for indexing and searching, classification of the data, recommendations, and then analytics. So these are most complex use cases. However, in order to explain you in simplest terms, here are some easy examples for you to understand. For summarization, basically you need to build an inverted index. So that's where MapReduce could be useful for you. Then top n records within the classification to identify the top n records, and then sorting kind of use cases under recommendation. So there are two ways to look at all these high-level use cases like recommendation, classification, and summarization. So most of these are similar to that of the machine learning kind of terminology, where we talk about most complex use cases, especially if I say recommendations. We all know Amazon, YouTube kind of internet or e-commerce kind of websites basically have built very interesting recommendation platforms, or even Apple kind of companies. Analytics could even stand for very simple analytics like doing the joins and selection. So coming back to MapReduce, basically, what is a MapReduce? So MapReduce is nothing but in a MapReduce job, essentially, you will have two different phases. One phase is called as mapper phase, and the other phase is called as reducer phase. It's nothing but, mapper is nothing but a simple function. Reducer is nothing but another function. Okay? Mapper is a simple program. Reducer is a simple program where you write your business logic into the mapper or into the reducer. So basically, for you to understand what is MapReduce, basically MapReduce is nothing but there are two different functions. One is mapper function, the other one is reducer function, or else just a program. Okay, then what are the features of the MapReduce framework? Basically, it's a programming model. It's been designed for large-scale distributed data modeling, and it's basically has a fundamental feature of doing the parallel data processing, as I explained just before. Okay, so let's get to the details of how MapReduce works. Okay, so far any questions, guys? Are we all good so far? I can take a few questions here. Okay, sure, excellent. So let me proceed here. So let me try to explain you basically what's the workflow of a MapReduce program. Okay, so for this, what I'm going to do is I'll take a very simple problem, which is the most fundamental problem, which is called as word count problem. Okay, so what do I like to do here is basically, given say 1 terabyte or 10 terabyte file to me, I would like to count the words within that particular file or files. Okay, I would like to extract the number of times every word repeated in that file or in that path. Okay, so that's my key problem. So let's say if I have a statement like so Edureka has advanced courses. Edureka is the most reliable online courses. Let's say I just taken some randomly some example here to explain basically what is word count. So in this file, if I want to count, so there will be say Edureka, the count will be 2. Okay, so and then has count will be 1. Advanced, okay, count will be say 1. Again, let's say if there are these lines are repeated in the same file, let's just take for example if these lines are repeated, then this will become 3, Okay, so let's see if I take is will become 2 because I'm just trying to count the words number of times it has repeated in that file or in that number of files. So this is the problem statement. Let's try to understand how Mapreduce tries to operate on this kind of problem. Let me take a very simple data for you to understand very quickly. So let's say if I have some data set like say river, beer, and then say near, then car, river, near. So beer, okay, car, that's a river. Okay, so I'm just taking some sample data set here. Okay, so let me just randomly pick another 2 lines. Okay, so folks, let's say that your file contains these words. You could ask me now, so why are you taking just a small file when Mapreduce is supposed to process some terabytes of file? Definitely, Mapreduce is not designed for this kind of small files. Instead, Mapreduce is designed to process very huge amounts of data, even though you could process even the small files as well. But for the sake of simplicity, to understand the problem, this dataset is suffice for understanding the problem statement here, folks. Okay, so let me explain here. So what Mapreduce does is, in short, basically it will divides the actual file into multiple pieces. Let's call those pieces as, say, input splits. So I'm just calling these pieces of data as input splits. So once that I have input splits readily available for me, then what I will do is, whatever the mapper function and reducer function I have created, I'll just try to run that mapper and reducer functions on top of this independent on top of this input splits. So what happens is, basically, let's just take some assumptions here because we are just having 1 hour, so it's very hard for me to cover everything. But let's try to get some try to take some assumptions as well. Let's take an assumption here saying that say for your mapper, the input will be a key and then a value. Let's take the key as a dummy key. So just ignore about what the key will be, but the value will be a line in each iteration. So for every time, your mapper function will get line as the input, a single line from your file as an input. So then what mapper will do is, mapper will split that line with white space characters and emit intermediate data, okay, which is again a key value pair. So once I split, let's say I'll take mapper here. Okay, so mapper 1, I'm just calling it as mapper 1, and then say mapper 2 here, and then I'm just calling this as a mapper 3, because there are 3 different input splits, and my function has been divided into 3, and then it's been running in parallel on all these 3 input splits. So if I take this piece of data here, if I split this line over here with white space characters, obviously I'll get river and then beer and then near. So what I do is, once I get the splits, I'm just emitting some intermediate key value pairs where my key will become the actual word and the value become a hard-coded value called as 1, because this 1 actually indicating that I have seen this term or this word river once. So that's why I'm just emitting this key as the word, and then the value as the count or the occurrences, the number of occurrences of that term, which is 1. So I'm just hard coding that value here, and I'm emitting that for the first iteration. For the second iteration, it will take the second line. Obviously it will emit, it will split, it will perform the same operation. So what is the operation of mapper? It is split and then emit, split and emit. So once it split this car, river and near, so there will be 3 keys. One is car, river and near, and a hard-coded value of 111. So obviously the output coming from this will be this will look like this mapper will look like this. Okay, so this is what it is going to do, my mapper. So exactly same way all the mappers will perform the same operation but on different data sets. So this mapper also obviously is going to do split and emit. Okay, so if it does the same thing, so there will be beer 1, car 1 and so on. Beer 1, car 1 and so on. So it basically all your mappers are operating on individual pieces of data, and they're processing the data and then emitting some intermediate records. So all these intermediate records will be pushed back to something called as reducer function. Okay, so something called as reducer function. And at the reducer side, let's say if there are two reducers defined for your Mapreduce job, say reduce 1 and then the reduce 2. So what am I going to do here is basically I'll take some data, let's say river here as the input, river with the list of values here. Okay, so with the list of values, say what are the values associated with river. So let's take this. So river as 1 here, and then there is no other repetition here. So let's see here. So again, there is river 2 times here. So there will be 1, 1, 1, and then river is appeared here as well. So again 1, 1. So ideally what is happening is internally Mapreduce framework is joining based on the key. So it is taking the key and then joining all the values and then just emitting a key and the list of values to a particular reducer. Let's say river, reduce 1. So if the reduce 1 is getting a river, so always it will get that river. Okay, and then it might, if it is getting car, so car will be here with all its associated values, because framework internally is taking care of joining all the values associated with that particular key, no matter from which mapper that key has been emitted. Okay, so now that reducer has got the data, what reducer will do is it will iterate over the list and do count. So it is iterating and count. So what will happen here? So when it iterates on all this list, so this is a list, right? So if it iterates, first time it will get 1, second time 1, third time 1, fourth time 1, and fifth time 1. So meanwhile it is also doing counting as well. So if it does that counting, or if it does that sum, let me change this, instead of count let me call it a sum. So if I iterate and count, do sum, basically 1 plus 1 plus 1 plus 1, so it will become 5, right? So reducer also will emit a key value pair. Ideally the key will be the term or the word, and the value will be the actual sum. So finally, after your Mapreduce job has been successfully completed, you get the count of each of those words available in that particular file. I'm sure there are a few things which will be quite confusing for few of you. It's because of the nature of the session itself. This is just to explain how in a high level how the Mapreduce works, but we are not really going into the detailed understanding here, folks. Okay, so now that we understood how the Mapreduce works, so basically it's a high level flow over here. You have the list of you have the file. So each input split is operated by a mapper like this, and mapper does some processing. Basically mapper is splitting based on the white space character and emitting the key and then the value. So all those are actually going into a phase called a shuffle phase, which I have not introduced you guys. It will be more confusing if I introduce you. So just imagine that shuffle is the phase where basically the join happens by default based upon the key. So once the data has been joined, then all your joined key value pairs like this, so key and the list of values will go to the reducer, and the reducer side you can apply some more business logic. Let's say in our case we are just doing the sum and finally emptying the final result. Okay, so let me move on here quickly. Mapreduce job submission flow. So you have the input data, you are splitting it into two different nodes. So let's say node 1 has an input split and node 2 has an input split. When I say node, it's basically nothing but it's fundamentally it means a machine. Okay, so since you are having a cluster of machines, let's say you are having two machines, you are just splitting the file into two pieces and putting it across two different machines, which I'm calling it as nodes. So input data is distributed across the nodes, and then in the next step each map task work on a split of data. So there will be n number of mappers based upon your n number of input splits. If there are n input splits, you have n mappers running for your Mapreduce job. Okay, so parallelly processing each of those input splits of data. Then mapper outputs some intermediate data. It does some functionality based on whatever the requirement you have. You just key in that functionality into that mapper, and it just emits and emits some intermediate data. So that intermediate data is going through some phase called a shuffle phase, and then coming back to the reducer, so where the reducer is performing some operation and then emitting the final result. So this is the whole workflow. However, we have actually hidden a lot of the technical aspects over here to make to keep the session simple and quick. Okay, so let's move on here. So how it works reduce sides. So now let's come back. Now that we have got at least some rough idea on what is a Mapreduce framework, in the sense that mapper is some program, reducer is some program or function, okay, and then you can apply those on each record, I mean each key value pair. So if you understand that, that's pretty much sufficient. So now that we understood that, so let's try to talk about the reduce side join here. So apart from keys, we are trying to tag to identify the source of the file from which the reduce side joins. So apart from the actual keys, what we'll try to do is we'll just try to tag. So let's do this here. Instead of just going through this text, let me first quickly show the data sets, and then we'll come back here and we'll try to understand. That will be more intuitive. Okay, so I just will try to quickly pull up the data sets here. Okay, so I have this customer related data which has this customer ID, first name, last name, and some information over here. Let's assume the customer age, and then here the customer's designation, and then I have second data set over here which basically has again the customer ID, then some date of birth of the customer. Oh sorry, this is not customer ID, probably this is social security number, and this is some date of birth of that customer, and this is customer ID. Then this is the amount of transaction, and this is something like the category. Then here is what the customer has purchased, then some blah 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 information, I mean the city and then the state, and finally whether it's a credit transaction or debit transaction. So now that we understand the data sets as well, let me quickly go to my virtual machine and start the Hadoop cluster. Okay, so I'm just logging into my Hadoop, my virtual machine, which I'm running on top of my Windows machine. Okay, so now that my virtual machine has already started, okay, so it's taking a little bit of time here to load. Okay, so now it's loaded. So now that I have started, let me quickly open up the terminal. So this is basically my VM is running a Ubuntu environment. Okay, so I'll give some time in the end to take your questions. Let me just quickly finish this program. Okay, and then I just will go to a directory where I have set up everything here. Then let me quickly start my Hadoop cluster. Okay, Hadoop 2.4.1 and then spin/start all.sh. So this basically starts my Hadoop cluster in the sense that it will start the data node, it will start the name node, it will start the secondary name node, also resource manager, and then node manager under the ARM framework. So let the services run in the background. Meanwhile, let me quickly go through the actual program. So how am I going to achieve the joins here? Reduce side join here. So folks, if you see here, this is a Java program. I mean, for who are not from the Java background. So import some classes. I'm importing some Java specific classes, which is IO exception. And then you can see here, most of the APIs are imported from Hadoop. Most of the APIs are imported from Hadoop, like configuration, path, text. So all these classes are from Hadoop. So in my class, which I'm calling it as a reduce join, let's start with the main method. There are three key components. One is main method, one is mapper class, and the reducer class. So in the main method, I'm just instantiating an instance called as configuration instance, which is required for the job to run in the Hadoop platform. And then I'm instantiating the job instance called as job, and then describing it as reduce side join. Set jar by class name, so I'm setting this class name as the jar class. Reducer class, what is the reducer class for my program, and what is the mapper class? I can set the mapper class as well. Okay, so let me quickly set the mapper class. So job.set mapper class, which is let's say this. Oh, okay, I got it. I got the idea. Okay, so basically what I'm trying to do is I have actually set the classes here. Customer class and then the transaction class. Let me explain you a little bit over there. So after I set the reducer class, then set output key class as text and output value class as text. Okay, so I'm just specifying my framework that what is my output key, output value. Now that I have defined most of the stuff, I have to now configure my mapper. So in this, you have got two different files. One is customers file and the other one is transactions file. Okay, there should be two different mappers processing these files. If you are having two files with customers data, you no need to have two different mappers. Since you are processing two different data sets here, I am using a map with two different mappers. So in order to configure this mapper, I'm using something called as multiple inputs for this job. Add input path, I'm passing the job instance and then the path where my file is located, and then the input format type as text, then the mapper class is customer mapper, and then input path same thing but with transactions mapper. Then I'm instantiating the output path as well. File output format that set output path, I'm setting the output path, and finally submitting the job to the cluster by calling the wait for completion method. So if I go back quickly here, I have my customers mapper class, which is extending the mapper class from Hadoop framework, and then overriding a method called as map method. So in this, basically what I'm trying to do is I'm taking the value, converting it into a string, and then splitting it based on the comma, because you would have noticed that the data is a comma separated value file, CSV file. And after that, I have split the data with the comma. Then I'm just emitting the first part of it, which is this one, first part of my customers file, which is this customer ID, and then the remaining part over here. But I am just hard coding some text like CUSTS over here before I emit parts 1. So parts of 1 basically contains this first name over here. Okay, and then in the transactions mapper, I'm doing pretty much the same thing. I'm splitting the each line based on the comma, and then emitting parts of 2, which is basically, you can see here, so 0, 1, 2. So 2 is basically my customer ID. So I'm emitting that as the key. So you might have understood by now, so how the join is happening, because the key is same here, emitted by this mapper and this mapper is same. And then text, so basically I'm hard coding something called as transactions, and then the parts of 3. So parts of 3 basically contains the amount of transaction here. So in the reducer, what I'm trying to do is basically I'm just defining some variables over here, iterating through the list of values based on the join. So we know that framework itself does join based on the key. So if it sees two different customer ID, the same customer ID coming from customer mapper and coming from say transaction mapper, it will just automatically does the join and just emit those list of values to it. So now that I'm iterating with the list of values, I'm just checking whether the value is starting from transactions. Then I'm just doing the sum. If not, I'm just hard coding that value as name over here, and finally emitting the name and then the amount of transaction over here, the count and total. So basically I'm doing the count as well as total amount of transactions. So total number of transactions and then the actual amount of transaction as well. So now that I have prepared my job and now that we understood the job, I'm just quickly exporting this job as a jar file, Java archive file. I'll call this jar file as, let's say, reduce side.jar. So now that I have defined the reduce side jar, okay, so here is my reduce side jar, which has been exported into my desktop here. I'm just copying it into my VM. So cp, let's say mod, and then HGFS desktop reduce side jar here. So now that my jar file is available here, I can now run a Mapreduce job here, folks. So in order to run the Mapreduce job, so I need to have that files located in my Hadoop HDFS file system. So let me quickly see where that files are available for me. mo-test. Otherwise, I can quickly copy those files. So I think it looks like I don't have those files. It's better I will copy these files quickly. So I'll just save again on my desktop as transactions, and then on my desktop as customers. Okay, so now that I have both my files in my host machine, so let me copy those files as well here. Okay, and then here, guys, we are almost done. Okay, so now all that I'll do is Hadoop fs-put. I'm just copying this customer's file into a path, say mr test. Okay, and then I'll copy the other file as well quickly, say, which is the file transactions, into the mr test again. So now that I have copied the data into the HDFS path as well, so all that I'll try to do is Hadoop jar, then I'll just pass the jar file name, which is reduce side.jar, and then the input path, the first input path should be the customers. So then the customers cus.txt, and then second input path will be transactions. So transactions.txt, and the third will be the output. mr test reduce join output. Okay, so that's it, folks. So now it says class not found. Okay, my apologies, I just forgot to specify the class name here. So the class name here is reduce join. Okay, reduce join. So that's it. So it has actually started a Mapreduce job, which we could monitor from the web interface as well to see what's the status of the job, folks. So even on the console itself, you can get the output as well. So you can go to the AND cluster, http:// localhost 8088 cluster. So it will basically go to the resource manager and will try to pull up the status of all the jobs currently running on. See here, you can see that particular application reduce site join has actually been picked and the progress bar also has been started. You can see the actual progress of the job as well here. So once the job gets completed, so now you can see mapper is 100% completed and reducer will start immediately. So after all the mappers are completed, then reducer will start. So before it comes out, so basically let us go ahead and see what's happening here. So files have been taken in the mappers, and then we are just tagging either it's a customer file or it's a if that record is coming from customer file, we are just tagging it as cus. Otherwise, we are tagging it as, say, transactions. So in the sort and shuffle, automatically will take care of joining the records based on the key, where the key was actually customer ID, and then we are just doing the counting and summing. So that's what basically all about doing the joins, folks. So now you can see the join has been successfully ran, and the output will also be there. Hadoop fs-ls, which is mr-test / reduce side, I think reduce join, say output. It may have generated some part files. So there is one part file. Okay, if I say Hadoop fs-text, it's like printing the file. Okay, if I do just say pipe more, it will quickly emit. So here is the person, here is the number of transactions he made, and here is the amount of transaction. So how will this analysis is helpful for me? It's basically if I want to understand, let's say top 10 loyal customers, I can write this kind of Mapreduce shop where I can do some sorting as well, and then can get the top 10 loyal customers from my database or from my HDFS file system. So folks, so that's how you achieve the reduce site joins. Anyhow, it's very short and fast. I know there will be a lot of questions as well, or there could be a lot of confusions around, because in 1 hour you understand, right? So how much we can cover. So ideally, the idea over here is basically to explain you how reduce site join works. So folks, if you have any questions, I can pick up your questions and then probably we can call the session down. Okay, so Nilu says, please explain the reducer in detail. So however, reducer is nothing but it's just a Java program. It's just another program, Nilu. All that you are trying to do is you're just defining your business logic in the reducer. So whatever the intermediate data which has been generated from your mappers will go into your reducer. But before that, what Mapreduce framework is doing is basically it is aggregating based on the key and sending the list of values to the reducer as the key value, key and list of values. Is that kind of clear, Nilu? And then Shiva says, can you show me an example? So Shiva, I did, right? Maybe this you have asked before I shown the example. Kulmani says, first, is it will divide as blocks, right? Absolutely, Kulmani. It will first divide the data into blocks. Okay, and then on top of it, it has a concept or notation as for input split. So there is a slight difference between a block and an input split. So block is physical in nature, input split is more logical in nature. So does that answer your question, Kalpani? I'm sorry if I didn't pronounce your name properly. Kamachi says, based on what criteria these input splits are sorted? So input splits are not sorted as such, but Mapreduce framework, whatever the output has been generated, that has been sorted based on the key. But your input split will never be sorted. Okay, it depends. I mean, if your input split you are getting from other Mapreduce job, it would have been sorted based on the key used by that particular Mapreduce shop. Is that clear, Kamachi? And then Ravikant says, what if same values repeat in the same line? It does not matter, Ravikant. It just emits that same value, I mean same word, and then the occurrence as 1, Ravikant. Then Chaitresh says, kindly provide us a reference material installing Hadoop on VM. Definitely, Chaitresh. We already have enough material within the Hadoop LMS portal itself. There you will have a step-by-step explanation on how to set up the Hadoop on VM. You can even request the support team as well. Hadoop@edureka.co. Okay, Raj says, can you also show the Scala program for this? So Raj, now showing the Scala program is quite difficult with 1 hour's time frame. So I believe you will understand about it. However, Scala comes into picture only when you are using Spark kind of framework. Okay, so in Hadoop, there is no native support for Scala. Hadoop is purely a Java-based framework. However, the things are changing slowly. Maybe sooner or later you might find a Hadoop totally built on top of Scala, but not now at least. Does that answer, Suraj? Ashish says, how can we have reducer join and having and or? Okay, good question. So that logic has to go in your reducer itself. Okay, so you can define that logic if you want to implement and or. You just define that logic within the reducer itself. Ashish. Because reducer is totally under our control, right? Even mapper as well. So Chaitresh's difference between Hadoop versus Spark. So simple difference is basically Hadoop is a batch processing system where it mainly relies upon the file system on the disk to do a lot of operations. Spark is mainly an in-memory data processing system. Okay, so I know it's kind of very vague, the difference. However, considering the limitation of the time, that's what we could cover for today. Chaitresh. Then Krishnam says, could you please give a short description on what is partitioner and combiner in Mapreduce? Partitioner is the one which basically decides how the keys will be distributed across different reducers. So that's the definition of partitioner. And then combiner is the one which makes your job more efficient in the sense that it does map-side joins as well. I mean map-side aggregation, sorry, not join, map-side aggregation, so that the amount of intermediate data being flown from mapper to reducer will be drastically reduced, through which you gain a lot of performance. I don't remember who is that. Krishna, I think Krishnam Raju. Then Kamachi says, how the input split are made, line by line or block by block? It's not really line by line. It's basically a block only. For you, just for the time being, you can just imagine like it's a block. But it's slightly different than a block, Kamachi, because it's a logical division of the data. So Gausuddin says, will shuffling occur first or sorting occur first? Very good question. So sorting, basically most of the people are under the impression that sorting happens at reducer side, but it's not true. Sorting first happens at the mapper side itself and also happens in reducer side. So sorting happens in both the phases, after the mapper has completed and before the reducer is about to start. Okay, so shuffle and sort both happens at the same time after the mapper emits the intermediate data, and that output being generated from that particular mapper, actually the data will be partitioned and then sorted. Then the shuffle phase happens at the reducer side, where you are, based on the key, it'll aggregate the values at the reducer side. Okay, so for this to understand in detail, we need to actually understand the architecture, or understanding the inner workings of the sort and shuffle phase itself. But in short, for you to assume, let's say, sort will happen first and then say shuffle will happen. Goes then. Manmohan Lal basically says joins and reduce side are done off memory, means RAM is not used for it. Joins on reduce side are done off memory, means RAM is not used for it. It's not really true. RAM is still there, but actually it has been happening in the partial data set, but not on the entire data set. Manmohan Lal. Obviously, it can't load the entire data into RAM, but it loads the partial data required to do the join and then does the join. It will happen in memory itself, obviously. Then Shishana says, what is the input split and the HDFS block? There is a slight difference. I mean, now it will be very hard for me to explain. Just imagine that, block is like a physical block, and input split is like a logical split on top of a block. Shishana. And then Amit says, okay, so how do I get the recorded video? You can contact the support team, Amit. You can get it once you contact them. Prostil says the number of mapper is equal to the block in HDF. It's not really block, but input splits. Number of input splits. Okay, Sushana says any difference. Okay, so Sushana, I just explained in a very high level. I hope you understand. Then Ashay says and is it possible? Can you tell an example covering OR condition? Okay, so it's basically whatever we have ran now. It's basically an OR condition itself. Okay, in your reducer, let's say if you are getting two records coming from mapper A and mapper B, let's say if one record is missing, it doesn't matter. You can still process that and emit whatever the intermediate data you have in your reducer. So you no need to necessarily filter that particular record in the reducer logic. That's how you achieve OR, Ashish. Shivagangadhar says, what is the identity mapper? Identity mapper basically takes each key value pair from your input data and just emit as is without doing any changes. Okay. Then there will be identity reducer as well. Krishnam Raju says sorting happens first and then shuffling. Yep, right, true. Manmohan Lal says, what sorting technique is used for sorting the data on mapper side? So, if I'm not wrong, it will be it will be general sorting, but I know about reducer side. So reducer side, it will be basically mode sort at the reducer side, but mapper side, it could be say bubble sort or whatever, quick sort maybe. So it depends over there. Then Shushana says, okay, so Ravikant says this is one of the good training which helps a lot. It helps a lot and clear. So thanks, Ravikant. Thanks for that. So folks, that's pretty much it from my side. Hope you guys have enjoyed this webinar. I tried to keep more informative as possible, considering the time limitation for us. Okay, so we tried to just understand at least one use case for Hadoop, which is reduce side join at a very high level. Okay, so thanks, folks. Thanks for joining, and I hope you guys all enjoyed the session. Okay. Shiva says, thank you so much. Yeah, thanks Shiva as well. Okay. Thanks Shri, thanks Kamashi. Okay, so bye everyone then. Okay, have a good night and have a nice day as well.